Hey folks, in tonight's 5-minute designs we are taking a look at this. This is a precision nozzle for a Ryobi low pressure inflator. There's nothing too awful special about it. It's just kind of a tapered tube, but it does have this little locking channel that keeps it attached to the blower itself. There are a number of ways to create this little channel, and each has its strengths and weaknesses. I'm going to blow past some of the obvious ones first and get into the sheet metal stuff, which is the interesting part of this discussion. So the most obvious way to create that little channel is to just create the sketch and then just push it right through the cylinder. That's obviously like the easiest thing to do. However, since the sketch is fairly wide in relation to the cylinder, when you do that push, when you do that extrusion, everything extrudes perpendicular to the face that you're extruding, so you're left with like some pretty significant angles on your cylinder walls. And those don't line up with the walls of the pin, so you're going to have to add some slop or add some adjustment there to make sure that the pin can actually fit in your heavily angled wall. So that's not the best option for what we're trying to do here. The second one is fairly straightforward. What I did here was I made a sketch for the lower channel. I pushed that through both sides. I created a 45-degree offset plane. Created the circular sketch for the right side and pushed that through. And then you're kind of stuck here with your vertical channel and then your hole for the right side of the channel, but there's no great way of removing this material in the middle. I can't create like an angled plane here and then push a square through a rectangle through, because the tops of the circle and the channel on the left, they don't line up. So if I align it with this outer circle, I'm going to end up with like this odd ridge in the back, and if I align it with the inner circle, then I'm going to end up with this odd ridge on the front. So what I did instead was created an offset plane at the pinnacle of the circle and the channel. So at the very top here, you can kind of barely see it, but it's there. So I created that offset plane and I split the body, and by splitting the body, that lets me recognize these individual faces between the circle and the vertical channel. So from there, I can just push those down, and now I have my cleared out channel between the circle and the vertical channel. So then you combine those back together. I needed to create the little nub there at the bottom, the little locking nub, with just a few more sketches and fillets. No big deal there. The third way of doing this is similar to the second, only instead of creating each individual sketch and pushing it through and then subdividing the bottom to push down the faces, I'm going to construct the entire cut piece before doing any of the subtraction. So I created my vertical channel. I extruded it into a new body. I created the offset, the 45-degree circle, extruded that, and these, let me get rid of that top. These are joined together. I created an offset plane again at the top at the height of those circles, so this offset plane here, and then drew a circle around everything, and then that gave me these surfaces that I could push down and combine with this kind of cut body here. And then I could subtract this from the outer shell. So if I bring that back, turn that off, as you can see, that's now cut out. So this is effectively doing the exact same thing as step number 2. The only difference is that I assembled everything that I knew I needed to cut before actually doing the cut. So if it's something simple, you're probably, it's just as easy to do the individual sketches and cuts. If you're doing something more complex that you're trying to cut out of a cylinder, then you might want to assemble the whole thing before you do the subtraction. But either way, those are decent solutions. But what we're really here to talk about is the sheet metal solution. So let me forward a bit. All right, so the first thing I did for the sheet metal solution, let me hide all of these guys, is I duplicated this bottom ring. So this bottom ring exists both as its own independent body as well as part of the top. So these two are overlapping rings. Then what I did was I drew a sliver and cut a sliver out of 1 millimeter sliver out of this ring, so now it's split here. I extruded a 0.5 millimeter straight extrusion off of one of the split faces, and now this is flat. If I was going to continue to extrude this face out, it would be a straight extrusion and form a rectangle out here on the side. It does not curve like the cylinder does, and that's very important to sheet metal. Because next, after you have this flat face, you can convert this object to sheet metal. It doesn't change the appearance of the object at all, but that does give you the ability to unwrap. So if you go to, you had to go to Create, Convert to Sheet Metal to convert the object, and if you go to Modify, Unfold, it'll let you pick this flat piece that you created, and then it will unfold that cylinder into the full-length rectangle. And this seems a little convoluted. Why would you have to create this flat part? The purpose of the sheet metal unfold tool is that you are designing something to be cut from a flat sheet of metal and then folded. I mean, the terminology matches up, right? So the thing that goes on the bottom, the anchor point for the entire structure that you're building, is this one flat face. If this was just a full cylinder, Fusion 360 wouldn't know, how to lay it out flat. It wouldn't know where to start to unfold the cylinder. So this is its anchor point, so it knows how to unfold everything. So now once everything's unfolded, you can sketch and operate on this rectangle just as if it was a flat rectangle. And then anything you do to this, Fusion 360 will know how to wrap that back onto the cylinder. So what I did was I created the same sketch that I used in the very first, the straight push through the cylinder. This is that same sketch. I pushed it through and took just the intersection. And you notice I left this anchor point alone. The only thing that it knows how to rewrap are things that are still attached to that anchor point. So if I was to create another one of these sketches way out here on the right, and then perform that same intersection, and this guy was kind of floating out here without being attached to this anchor face, it wouldn't know how to rewrap it. It would just leave it out there. So you have to leave this anchor face alone, and you have to attach everything that you wanted to be refolded to that anchor face. So with that guy created, I can refold, and as you see here, when it refolded, it wrapped the solid body around the cylinder instead of just a straight extrusion. These lines would have all been straight cuts through the walls in our first example, whereas now they are all oriented towards the center of the circle. So from there I created a axis in the middle of the circle. I used the pattern copy to create an opposite version of it. I extruded away those anchor points because I don't want to cut those out of my cylinder. And then I cut... One second. Then I cut those pieces out of my cylinder. So that allowed me to translate a two-dimensional drawing onto a cylindrical surface. It would be nice if Fusion just gave you the tools to do that. If they just gave you the option to, essentially unwrap and draw and then rewrap. But they don't do that. They go through this sheet metal mechanics thing, which has all these limitations. You have to have this anchor point. Everything has to touch this anchor point. Everything has to be the same thickness. So if something goofy happened to that cylinder and maybe the inner circle was slightly offset, so it was 2.5 millimeters at one end and 2 millimeters at the other end of the circle, then it wouldn't know how to unwrap and rewrap that. It would fail to do those operations. So there's a lot of restrictions, and those limit the usefulness of the tool. But if you needed to wrap something around the cylinder, this is one way to do it. So that was creating a pretty trivial little attachment point for this nozzle. Let's say we wanted to do something a little bit cooler. I'm going to create a new drawing here. And I need 2 circles. Let's go with 40 millimeters and 42 millimeters. So that's going to give me a 1 millimeter thick ring. I'm going to pull that up 30 millimeters. I'm going to split this just like we had to split the previous cylinder. So the easiest way to do that is to draw a line, and then you can use the offset tool to give you a second line. And then we can just push this guy down through the other end. Now we need an anchor point, so I'm going to pick one of the faces from that cut, extrude that just a 0.5 millimeter. And now that is our flat face. From here I can go into the sheet metal tools. I can convert to sheet metal and pick my my flat face. So now that is a sheet metal object. I can go into modify, unfold. It's first going to have me pick the stationary entity, that's that flat anchor point. And then it's already got the bends and folds selected, but you can if you had multiple things coming off of this flat face, you could choose to unfold just select faces. But for now, we're going to go with all. And then now I can sketch on this surface. So I'm going to create a new sketch and use the text tool. Kind of center it a little bit. And now we can extrude that guy. And then refold everything. And now we have our text wrapped to the cylinder. If you just wanted the text, like let's say you didn't want the cylinder, it's easy enough to just pick the profile of the cylinder and extrude it away, and now you're left with just the text. Oh, gotta get rid of the anchor as well. But you get the point. You can get just the text out of that as well. Now, if I was going to go the opposite direction, so let's go back to where it's unfolded, and instead of extruding out this text, let's say I pushed it in, and now you can see it performed the cut, but all of these free-floating pieces and the B's and the G's and the P's, all those free-floating pieces, they kind of turn this transparent color. They're still there. They're still objects, but when we refold, they're not going to make it. They're just going to be left floating out there, and our refold is going to have blank spots in it instead. So everything has to touch that anchor face, the stationary face or whatever they call it, or else it's not going to work. What you could do as well, if we did leave this extruded like it is, we did do the refold. There's nothing to stop you from, subtracting this, and you can't extrude this back through because it's on a curved face. So I can't just push this G back in, but I could create another cylinder, at the boundary of this one, and use subtraction to kind of stamp it into that new cylinder. The other thing that it doesn't work with, and this would be cool, and I don't totally get why it doesn't work, but you would think that we could create kind of this wavy guy here, create an offset for him, seal them up. We'll extract him. And same thing here, since this is wavy, we'd put in our 0.5 millimeter flat face. So you would think that it would be able to kind of unfold and straighten this, and you could put text on that. It'll let you convert to sheet metal. However, if you try to unfold this, it says not connected to any bends, so it doesn't see this as something that it can unfold. So no wavy text, at least not using the sheet metal tool. You can always type it into a plane and extrude it and join it to the surface, and then cut off the excess. You can trick it a little bit, but you're not going to get that the text that is perpendicular to the face of the wave at all points. You're going to have to kind of fudge it a little bit. So a lot of restrictions on the sheet metal tool, but if you're trying to put something on a cylinder, in particular something like these grooves for this locking pin, it works pretty well. So I hope you found this video valuable. If you liked it, hit that like button. If you liked all my videos, please subscribe, and I will see you in the next one.